Hi, welcome back to this series on creating a virtual console with an AI assistant. Apologies if there's any strange noises in the background. My dog has just decided to noisily chomp on a chew. I think I've waited until she's finished, but you can never be sure. So we left the last part with our CPU class created, and we had a quick scan through it. It mostly seemed okay on the surface. I've had a look afterwards. I've noticed one thing that isn't right, which we'll come back to. I've spot checked some of the instructions. The ones I've checked seem to be correctly implemented. But in this episode, we're going to do two things, and we're going to do them in parallel, which is often how I use these tools when I'm working in the day. We're going to start by setting off Claude, building out a little example explorer for us, for which I've written a spec, which I'll talk through. And while it's working away on that, we're going to look at writing or getting Claude to write some tests for the CPU. So we'll write another spec while it's executing the first spec. And I'll probably have to dovetail back and forth because it might well come back and ask me some questions, but we will see how it goes. So the spec I wrote for this is, let me see if I can find it in here, in Tools, CPU, Examples. And basically I want it to give us a little kind of in-place console view that doesn't scroll, so it just updates itself in place. Excuse me. As per usual, we want it to read our various files, so it understands the context of what it's working against. They're the files I've already got, there's nothing new there. I'm asking it to use TypeScript, again, nothing new there. I'm asking it to use the Ink framework, which I'll open in a browser. Sorry, excuse me. I had not used this before until I thought it might be fun to use something like this in this thing, and I experimented with it the other evening. I'm not an expert, but it's basically React renderer for the console. It looks pretty cool, and we'll see how that goes. So we'll use Ink for that. I want it to basically have two parts to it: a menu, which is going to present a bunch of sample programs that we want to be able to run. And while it's running, we are going to have a classic kind of hex display. If you've never seen one before, hopefully at the end of this we can look at one together, actually running. We will see. But it's basically three columns, or actually there's some sub-columns, but three major columns. The first column is the base address of a row in memory. The middle section is the hex representation of the bytes, and the right-hand section is the ASCII view of the bytes. And then traditionally you would display non-printable characters of a space or a dot. I'm using a dot and colouring it a darker grey, or I'm asking it to colour it a darker grey, so we know they're not actual ASCII characters. I've basically given 16 rows for that, giving us a window onto 128 bytes of memory. 16 times 8, there's 8 bytes in each row. And underneath the hex display, I want it to show us the registers, so what's in the registers, the stack pointer, so what the stack is pointed to, the program counter, and then break out the status flags, as you can see here, so we get a view of those, and also shows the disassembled view of the instruction at the current program counter. The disassembled view is when you take the byte representation of the instruction and convert it back into the kind of human readable assembly language. So that's what I wanted to do. I've asked it to create a bunch of, first of all, we'll move to that. To run an example, I'll give it some instructions about how to set up an example and run an example. I'll give it some basic guidance about the memory space. Then I've given it a bunch of example programs I'd like it to run. I use an LLM to generate some of those. I generated a couple myself, and then I asked for some more programs that would fit into the space constraints that we had, and I got those out. So the other thing I want to say about this kind of experimentation tool, this example tool, we're not going to pay too much attention to the quality of the code. Mostly I just care if this works. And this is one of the things I think is interesting about sort of LLM generated code is you start questioning where the value is in terms of code quality. some stuff essentially becomes throwaway. So I would have had to take a few days to, I don't know how long it would have taken me to write this. We'll find out how long it takes me to write it with an AI. I don't know how long it would have taken me to write it, or to take me to write it in in code, to do it manually. There's a few chunks to it. I mean, not forever, I don't think, but it would be an investment of time. And I'm hoping with the AI, it's not really an investment of time, and it's just a case of set Claude running, answer some questions, and we get something vaguely workable out of the end. And when you can create tools like that, that the kind of final output doesn't matter that much. They're somewhat disposable. Does it really matter how good the code is if I can recreate it again really quickly? And people sometimes say, well, if you want to come and change it, well, I could throw it away and ask the LM to do a new version, and ask the LM to change it. So I do think code quality is important, but I think you have to sort of put that in the context of what you're trying to do. This is a side tool. We're not too interested in it. We just want it to work. And I just want it to work so I can show everybody the CPU working and see it working myself. The focus is not the tool, it's the output. So I think there's some interesting things there in the sort of, when you have a tool that can generate code, at the speed it can, it does start to reframe your perception of where the value is in things like code quality, which is probably heresy to some people and deeply upsetting to some people. But to me, code is not a end in of itself; it's a means to an end. I will happily, throw it away for something else if I can meet that end in a different way, and if I can meet that end through writing a spec, and it fulfills my requirements. Including the broader requirements like maintenance, like being able to extend it, etc., then that's okay with me. As I said, there's other stuff, the CPU itself, I do care about the code quality. We're going to use that, evolve that. It's a core piece of it's what we're building. We want that to be of decent quality, and it's not, ultimately it's not going to be disposable. This is somewhat disposable. So we'll see where we get to. Let's see what happens. Okay, let's start Claude. I'm not in the right folder. Let's go to let's go to the folder and Claude. Start at Claude, and then I'm going to ask it to implement the to read the specification in source. In specs/tools/CPU examples.md, and ask me any questions you have before proceeding with implementation. So let's see what it does. This is very quick. Typically, my dog Rafi has gone downstairs now, finished munching a chew, and gone downstairs. She will probably be asleep. She might reappear. She often does. Okay, so it's read the files I've asked it to. That's good. It's now having a bit of a think. Okay, let's go through these questions. Disassembly. Okay, should I input a basic disassembler? Yes, I'll ask it to input a basic disassembler. Disassembly. Let's go back to a slightly different way. I sometimes either update the spec, sometimes, I mean, you've got two choices here. You update the spec with the answers in, or you take this and answer its questions kind of in situ. In this case, I am going to take its questions and answer them in situ. So in here, I'm just going to create a new one of these. And in here, I'm going to say implement a basic disassembler. For that, we're going to say it should stay fixed. We don't want it to scroll. We're interested in 128 bytes. Okay, pre-populate the memory test data. Yeah, so it's asking, you know, should I write some code to create the data? We just wanted to pre-populate the memory with test data for tests that require some data. We'd like to see the stack inside the memory. I'd like to see its stack getting extended. It shouldn't get extended much. There's not enough code for it to end up with lots of lots of bytes in there. So we say we'd like to see the stack inside the hex view. So it should be set to the end of our 128 byte memory space. Why don't we have it show the register values as both? Yes, we want 4-digit address displays. Catch and display the error and return to menu. So errors, we just want basic memory detection. My suspicion is if anything goes wrong in this, just based on its training data and the complexity of the things I've asked it to do, I suspect it will be the assembly of the programs that goes wrong. In the spec, I've asked it to assemble the programs because we don't have an assembler. Essentially, hand assemble them, and that might be spicy. We will see. Yes. Show a message. And on the next key press, go back to the menu. I basically said use NOP. We've got our no opcode, or no operation rather, opcode. So let's say, and then for menu navigation, we'll say use arrow keys and enter, or press a number. Okay, so we'll take that. And we're just going to paste it back into Claude. And if it starts working, we will start to create a test spec. Okay, great. So I'm going to keep my eye on it because I might need to press, sort of OK, authorize it to do things a few times. So it should have persisted authorizations in the .claude folder here. So hopefully we won't get asked too often. Okay, cool. We're not interested in this anymore. We can get rid of that. It hasn't persisted because it's doing things in new folders. Okay, so it's using this will be putting a package.json in CPU example. Okay, fine. We will allow it to do all things in this session. I'm sticking my previous strategy. I've committed things. Worst cases, I just check things out and we go again. So I'm sticking with that strategy for this. And then here we are going to create a new spec while that beavers away. So we're going to put specs implementation, new file, CPU impl tests.md. Okay. I've got some notes on my other screen, so if you see me flicking my eyes over, I've got some notes on what I want my test to do. Funnily enough, I have thought about this in between sort of recording episodes. It's hard not to, doing it completely raw is, it's doable, but it would require me to be able to get to my PC when thoughts strike, and that's not really going to happen when I'm out walking the dog or at work. So I've just caught myself to capture some notes. So we're going to call it CPU tests, and we're basically going to create a test suite. Suite for the CPU class that you will find in source/console.cpu. Now we want to make sure that it picks up it uses the reference as our spec as the guide for the tests. We don't want it to base its tests on the code, so we'll try and steer it in that direction. You can tell it's late evening. I'm better in the morning than I am in the evening. But you can also see this thing is beavering away, creating things, so that's good. But while it continues, we'll keep doing this. So we want to say you should base the test suite on the specification you can find for the CPU in specs/hardware/ I remember what I called it, cpu.md, and only use the source code for the CPU as a guide as to what methods to call to drive the tests and perform the assertions. So try and steer it towards the guide. If I just said test this, it's going to read the code and create tests for what's been coded, which ironically is what I have observed many people do, many humans do. They read the code and they test what the code does, rather than read the spec or implement test. And you could go down a rabbit hole with TDD, etc. Some people struggle with it. I struggle with TDD. I find it easier to just work on things and write tests, and some people thrive TDD. Fine, as long as, again, outcome, not means to get there, is always my focus. And I've always tried to recognise, both when I was a developer and now I guess as a manager, although I'm still very hands-on, I try to recognise that everybody's different. We all work in different ways. This idea that everybody should follow the same process all the time is, to me, is nonsense. People are different. You're trying to force people into holes that they don't fit into, and then you wonder why they're miserable or things are going wrong. It's crazy. It's cult-like, and I despise how that stuff has infected software development. It's absurd. I find it ironic that a bunch of people who think they're really smart behave so stupidly sometimes. But anyway, that's just my view on some aspects of modern development. By no means all aspects, and by no means all people. But there are certainly a subsection of people who I think are misguided. That's the word I'll use, misguided. But feel free to disagree with me. That's completely fine. Anyway, we're going to get back to this. Yes, so I have my notes. What I wanted to do. How do I want my test to work? Right. So I want the test to work in a specific way. Right. You should construct the tests on a per opcode and addressing mode basis, being sure to cover all valid addressing modes for each opcode, and frame the tests like this. 1. Construct a memory bus containing the code, the bytecode for the instruction on the test. 2. Set the program counter to point to this bytecode, to this instruction set, to this bytecode. 3. Run the instruction in the CPU. Then, having done that, we want to assert for a few things. 1. That the status flags are as expected. That the stack contents is as defined in the specification. We can see red on the left. I assume it's building things and figuring out its errors. 3, that the cycle is consumed by the instruction are as defined in the specification. 4, that the content of registers is as expected. 5, that the contents of any referenced memory is as expected. So we're just trying to drive it to the spec and test the main components of a CPU. It needs my input. Is it okay to run dev? Yes, it's okay to run dev. Okay, while it keeps beavering away, we'll finish this off. Finally, implement the tests using vytest, and be sure to follow the TypeScript style guide you can find at specs/typescript-guide.md. Anything else in my notes? No, but what else? Anything else I can think of now? Mainly, I think we want the tests to be independent of the other components of our solution, so that add more tests for for more virtual hardware and run them in isolation. Okay, so I've mentioned the specs. I've given it the CPU. I've given it the spec for the CPU. Great, that looks about right. Ask it to check the status flag stack cycles consumed. Okay, so right, we're in pretty good state, I think, with that now. Great, so we'll see what this is up to. It looks like it's a fair way on. Let me have a. Oh, yes, you can proceed. I'm a quick drink of my alcohol-free beer. I'm a wild man. Okay, still looks like it's doing things. That's good. Okay, so it thinks it's working and it's shutting the process down, so we can go and run it. Interesting stuff. We're nearly there. It's going to be interesting to see what we see. Will we see what I described? I've got a picture in my mind. Is it the same as a picture in the AI's mind and everybody else's mind? We're about to find out. Quite exciting, really. I think it's just finishing off. Okay, it thinks it's done, so let us go to, pardon me, examples, CPU example, okay, I shouldn't need to, I should have already installed things, I should imagine. Yeah, it's already there. So it's npm start. Okay, look at that. We've got a menu, and we can up and down. Okay, can we do a memory fill? I'm just going to press 0. We can do a memory fill. Okay, we're looking at hex viewer. This is looking pretty sweet, but I can't see the current instruction is NOP, so that doesn't look right. Yeah, it's looking at zeros, so this doesn't look correct. So we're going to have to. It looks like it's just startup because it's revised itself. Okay, so there's a little glitch when it's there. It started, but it started kind of empty. I've pressed space and it's loaded itself up and run the first instruction. So there's a little bit of, it looks like there's a bit of out of sync between the startup and the display. So let's go back to Claude. Let's stop this. That's a pretty good attempt, though, I would say. I mean, that's pretty sweet. There's some opcodes. They do start at byte 32, which is what I asked for in the spec. The stack we assume is here, but there's nothing on it at the moment, so it's a pretty good start. Let's go back out. Let's quit. Go back to Claude. Okay, when I picked an example, the hex display opened, but it was showing all zeros. Then when I pressed the space key to move on, lots of content appeared. It looks like there's a sync issue on startup. Okay, let's see what it says. A sync issue on startup. Okay. I'm glad it felt I'd done a good catch there. I always love to be praised by the LLM. Makes my day. Okay, great. So let's go back to our console. Let's run it again. Let's memory fill. Okay, great. It's fixed it. It was a sync issue, and we can see it's sat looking on load. So it's loading a number into R0. I've not looked at these programs, so I have no idea what they do, and I am now unpicking these in real time. So it's loading 0 into R1. Okay, loading 0 into R2, 0 into R3. Okay, so it's set up R2 and R3 as the pointer into memory. So this is using a register index mode. I forget what it's called because it wasn't on the 6502. This is the one that I picked from the Z80, but it's using that as a reference, and it's storing the contents of R0 in that memory location. Okay, AA. Okay, so it's going to go through, I guess, and okay, so it's incrementing R3 and R1, comparing R1 to 16. So that will be the end of it. Branch if it's not 0 to, so it's going to go back to the store. Okay, but it's going to be incremented the memory on 1. Yeah. Okay. Okay. Yes, it's just looping around now. It's basically built a little loop. I think it's going for 16. I said so. It's going to go 2 rows of this. Okay, so we should now see it. Its comparison. Yes, it should now say this branch if not 0, but this. I can't go back, but it should pass this now. It shouldn't branch back. It should continue. Yeah, to the NOP. Okay, yeah, branch if not 0, comparison not 0, branch to this point, which is the NOP. The previous instruction must have been the go back instruction. Okay, and that's it. It's done. Press space here. It should say program finished. So we've got a little program runner. It's assembled it. It's using our CPU. It's dumping the memory out. That's pretty cool, I would say. I'm quite pleased with that. Quite excited about that. We can see our CPU working. We can see it running opcodes. We can see it updating memory. That's awesome. It's made my evening, really. I think I should finish now. But we won't. We'll run the tests. I'm going to commit this. There could be problems in the other programs. What I will do is, because we need to get cracking in the tests, I will take a look at the other programs kind of offline, and if I find any problems, if there's anything of interest that's worth fixing, I will sort of store those up and we can go through them at the start of the next session. And that seems to be a sensible use of time in terms of recording. Else I be here forever, and I don't think people want to watch too much of me prattling around. If you feel differently and you want to see everything, let me know in the comments. That's fine too. I will do what I can to accommodate, but I have limited time as well, and I sometimes have to fit things in around other things. But in any case, that's looking pretty good. I'm going to back up a few folders. I'm just going to add things in. Okay, we're not going to look at the code. As a missing git ignore. So we're going to have to unstage that. Okay, there's a missing git ignore file. So it's put all the it's put all the goodness, what's the command to unstage things in git? Well, easy way to find out. I can't quite remember it. I think it's dash stage, but I can't remember quite what. Okay, and how do I use that with a specific folder? Okay, we can do that and then just do the node modules. I think that will be enough. Okay. Okay, so then let us edit the git ignore. I don't need to do that, it's already open. Okay, it's not in there. Okay. Great, okay, so added a explorer for the CPU, yet to be fully tested. Okay, great. As this is good, I'm going to exit this Claude session and start a new one. So let's just start a new one. And I'm going to ask it now to implement our tests. Copy path. Okay. Doesn't need all that, does it? Okay, let's see what happens. Okay, it's thinking away. Reading out its package.json. Okay, so looking at the other package.jsons. Hopefully it doesn't do too much with them. Not that interested. Okay. I could always fill in more dead air with wild opinions on software development. Maybe I should create a little notepad on James's heretical opinions on software development, and we could plug through them during Claude time in future episodes. I will do that, and hopefully I won't get myself into too much trouble, but you never know. Cranky developer let loose on YouTube. Yeah, I'll create a little notepad of things we could perhaps talk about while waiting for Claude. Yeah, I think I will talk about the value thing a little bit. I can ramble about value forever. I think the value thing is really interesting. I think the questioning the value of things and where value lies is always a really healthy thing for a developer. And I think that comes at every aspect of software development. You should question requirements and what value do they give to customers, because sometimes they're thought through in those terms and sometimes they're not. Product managers, business analysts, product owners are humans just like software developers, and they have their own foibles, good days and bad days, and sometimes things are just not well thought through. In the same way I sit down sometimes and I produce complete garbage. And then either I realise or somebody says, James, you're creating complete garbage. This has no value. Everybody's human, so you should question the value of everything. And I think you should challenge assumptions around value. I do feel it's perhaps heretical to say that the code quality of that tool doesn't matter. But I think that's a really valid question to ask. If I've got a tool I can regenerate really easily and quickly, does the code quality of it matter? And we could talk about things like security and all those sorts of things. So I would never, if you're going to take a piece of code that's been, I'm desperately trying to avoid the term vibe coding. I hate the term vibe coding, and the commercial director where I work had a very good laugh at my expense of a vibe coding joke the other day. I hate that term. But you should never kind of vibe code up something that's going to run in, say, the cloud of customer data. That's a terrible idea. A terrible idea. And in fact, when I work on sort of AI solutions, security is first and foremost in my mind. I won't let an AI anywhere near a security kind of piece of information. You can't quite guarantee what it'll do, so it's you have to be very careful. And the same goes for code that an AI is generated. You can't be sure what it's really done. It could be full of security vulnerabilities. Who knows? So code of that nature, you absolutely have to review and understand what it's doing. But a tool you've created to run on your machine to do something for you that's really simple and you're not that bothered about, that's running tests, okay? Are you that bothered by its code quality? No, it's a fair question to ask, and I think when we have tools like Claude Code and other generation tools, I think that's a question we should be asking more and more. How much do we care about quality, and on what axes do we care about the quality? I mentioned security, functional quality, sort of cleanliness of code. There's all sorts of different ways this can manifest, and I think you have to. When you have tools that can create things at speed and at scale, you have to make conscious decisions about where the value lies and where you're prepared to apply a human effort to sort of bolster that value and ensure it does what you need. And I think they're really important questions to be asking, and I think they're really important things not to just assume, because the danger is, I say it's a danger, I'm sure it's happening now, people are treating AI generated code like code has always been treated, which in one hand is fine, but it was never okay. There's nothing changed. I'm arguing myself around and saying something almost as in opposition to what I just said. You should always test these things and evaluate these things. The fact that the AI created it is neither here nor there. Are those things valuable or not? Is speed more valuable than quality on one or more axes? You have people who cult-like declare that clean code is the most important thing ever for all these reasons, and if you don't do it, you're some kind of sinner. It's madness. I mean, it is madness. It's an extreme viewpoint, and it's madness. You should be questioning the value of how much time you spend making the code clean in your context. But I've filled enough time with my heretical views. It looks like we have some test cases, and it looks like they're passing. Let's have a look. Let's see what's happened. I couldn't see the window, so I don't know what's happened. I was too busy ranting. So let's find out what's happened. We've got cpu.test.ts in our console folder. Okay. It's put the package JSON in the source folder, in the root, which I don't think I like. I don't want that there. So we'll look to move that under the console. Yeah, I don't like that. Okay, so I want that self-contained under the console project. And created in the root. Under source/console. I want that to be isolated at the console level. Okay, so we'll let it do that, and while it does that, we will take a look at the tests. Okay. So it's created a little instruction encoder. So it takes some opcode, takes a mode, takes a dest, takes a source. So that's encoding the bytecode. 2 bytes that represent our instructions, and there could be a 3rd byte and a 4th byte depending on what the instructions are. I assume when we look at the tests, they will feed that data in as additional bytes if necessary. Set up and execute. Okay, so it takes the bus, write the bytecode to memory, set the program counter to the start address, and then run the instruction. So that's running a test. Okay, yes, we'll let it do that. I really don't care what it does in this source downwards folder. I say I can always undo it, so I'm not too fussed. Run invite test absolute path. Why is it trying to do that? Well, let's see what it does. I think I have to go and pick something else in a minute, but let's see what happens. Has it moved them? Yes. It has moved them at least, so they're all now in here. Okay. I'm not sure I like this structure either, the packages next to the source, so I might want to put, I don't like the idea of source, console source. I'll figure that out later. There's no point sort of wasting people's time on that. What's it doing? It's still running tests. Yes, just run the tests. Okay. Register. Okay. Yes, we need to check on this. I'm trying to do 2 things at once now. That's the other danger I find. I was falling into that trap there. You can multitask with these agents, which is great, but it's too easy to do it, and you end up paying not enough attention to anything. It's running the tests again. Okay, I'm okay with that. So yeah, you need to be a little bit careful about your sort of multitasking. I think it's easy to get seduced into this whirlwind of productivity where you're leaping between consoles and editor windows. I did it there, and that's dangerous. That's when you start to make mistakes and not see things. So yes, I think multitasking with AI is positive and useful, but you can get yourself into trouble with it too. So you just need to be a little bit careful. Let's see if we can run the tests actually from the console. Let's go into source console. Okay, npm run. I forgot. I didn't see what it said. Npm test. Okay, npm test. Okay, so it's run a bunch of stuff. It's run a bunch of tests. There's our vitest output. Vitest. I call it vitest. Don't know if that's right. Okay, so it's created a bunch of sensible seeming test cases for our extended instructions and our standard opcode. So that looks really good. Okay, it's doing what look to be sensible things. Okay, one thing it has done, look, it's I think because the CPU source constants are not exported, it's used the absolute values, so it's used load as a magic number. Let's get it to change that. Using magic numbers for the opcodes. X1 rather than load. Can you export the consts in CPU.ts and use them in the implementation file? And use them in the tests. The opcode. Yeah, that's fine. And addressing modes, it'll be the same. It's done the same, yeah. Addressing modes, etc. Okay, so let's get rid of the magic numbers. I think this will work. Yeah, I'm absolutely right. A friend of mine really didn't like the tone of ChatGPT, so he put in a global prompt to get it to be less personable. I think it went militant and turned on him. Cool. It looks like it's doing what we want. Look, it's changing the test to use for constant, so it'll be more readable. We hope. Okay. I think this non-alcoholic beer, or it's a 0.5% one. I think it's called Ship Tide. I get it from Ocado. It's surprisingly good. Okay, churning away. I'm not going to do another heretical conversation. I think one per video is probably enough. Although it's unlikely I'll run out of views. Let's paste them. Creating a new version of a test file. Well, if you listened to my TypeScript style guide in the first place, Mr. AI, you wouldn't be in this pickle, would you? This is one of those things where it feels like it might have been easier to say to it. You sometimes don't know if you think in advance. I mean, the thing with the tools is they are not deterministic. I know that's a cliched thing to say about LLMs now, but they really are not deterministic. And when you see it doing something like this, you sometimes think, actually, it might have been easier to delete the file and improve the spec and go again. Sometimes you won't know until you try it. You won't know until you try it. So I'm wishing I'd done that at this point, but it looks like it's got a good way through it, so we'll leave it. And again, I just add that's the sort of importance of creating commit points you can roll back to, particularly if you're letting it make changes without reviewing every single one. It can go crazy. It can go crazy. I was listening the other day, and it did. It wasn't on this project, on a different project. It did delete a file. Strangely, it seemed to fail. Writing an update to a file and kind of rather than fail nicely, the file went missing, and it recovered it from its cache. But when I asked it where the file had gone, that was a little bit strange. Shut this down. I don't know what it's doing here. So it's made the exports, by the looks of it, sensible. Look, they are now exported consts. I suspect we'll use that in the assembler when we get to building the assembler. So that's a good change to make. Okay, it's going to run the tests. Okay, let's see what happens. Yes, run the tests. Same number of tests, so that's a good start. Okay, cool. That looks pretty good. That still it's got more magic numbers to work through. I should definitely have asked it to just start again. Yes, you can always run this. Okay, great. Let's try it in the dev tool. It looks like it might already be running. Look, I left it in watch mode, so presumably they will never pass. Okay, so that looks better. Just setting values, op-add, register, 1020, looking for 30. Cycles 1, I'd have to check on add. Adding 2 edges to cycle 1 sounds right. So a quick look. Let's search for add. Yes, that's an example. That's not what I want. Address, add. That's not good. With particular, we go add. It was register, wasn't it? Cycles. Where's my cycle spec? Register, bytes 1. I thought I'd said everywhere what the cycles were, but one byte per cycle is right, so 1 cycle is fine. I think that's okay. I will double check that. I thought I specified cycles for each one, but maybe I've done so generically. Let's have a quick look. Instruction cycles. Here we go. Yeah, they're here. So register, add. Yes, register operations are 1. Okay, fine. Couldn't quite remember. Yeah, so that's correct. Great. So I'm going to do the same with this file. I am going to commit these files, and then I'm going to do a little bit of sort of offline after the video housekeeping. I'm going to sort out this folder because I don't like this and think about what structure I want it in. And I am going to review the tests against the spec, and like with the code for the Explorer, for the CPU runner, I will do a sort of offline review, and anything notable we'll fix in the next video. Anything kind of pointless and boring I'll just sort out. But let's have a quick look at the example it created. Okay, I wonder if that package.json was also for this because it's not there. So I'm probably going to need to sort this out. Yeah, I suspect. No, it only had dev dependencies. So it didn't have the package.json for that. It's here. That's why it's in the examples folder. Okay, yeah, fine. CPU example. I'm not used to VS Code, to be honest. I need to. Oh, there they are. Okay, they're there. The files are there. I'm not used to VS Code. I tend to use WebStorm for this stuff, so I'm getting a bit confused. Slightly different views of these things. It's copied the CPU over. We don't want that, so that's bad. Immediately, that's not good. Okay, that's bad. So we're going to get to reference for CPU. Shall I do that now? How long have I been recording? I didn't really start tracking time. Okay, let's see if we can fix that now. Let's start a new session. I'm going to first commit the changes for the tests. Okay. CPU tests. Okay. I'll push these up to GitHub. Okay, so they're all available if you want to go and check them out. And then we're going to go back into Claude, and we are going to ask it in source /examples/ CPU example. You have created a copy of CPU.ts. You should reference the CPU.ts module in source/console/. And the same applies to memory bus as well. Look. So although I don't care about the quality that much, as I say, it's a bit throwaway. I do care that it always uses the latest version of the CPU, because if there's going to be something wrong with that CPU, I know the test passed. But we've not reviewed the test in detail yet. I've spot checked some of the opcodes, but I don't believe I don't believe there's not a problem in the CPU. There's almost certain to be. And we'll find out at some point, probably in the middle of a perplexing bug when I'm writing some assembly code and seriously out of my depth. That'll be the point we find the subtle bug in the CPU. But real CPUs have subtle bugs in too, so we'll be in good company. Okay, so it thinks it's done it. Okay, so it looks better. Oh, that's not the wrong thing. Okay, cpu.ts, that's the old file, that's the right file. Okay, disassembler.ts, it's now referencing a file. Okay, let's go into examples, CPU example, npm, can't remember what the command is. npm start. Okay, looks okay. See if the memory fill works. Yeah, okay, so it's fixed that for us. Yeah, I do care about that, even if I don't care particularly about say the code quality in general. But it looks like it's done, something vaguely sensible. We've got an app.tsx. I guess we've got menu.tsx. Okay. And we've got a hexviewer.tsx. Great. Okay, pretty cool. Pretty cool. Yeah, so I'm going to leave it there for this session. Oh, I wonder where they were. Pardon me, register display. Okay, a register display.tsx and a run mode. I mean, it's just React code, but using ink, using the different rendering components. So pretty straightforward. Yeah, great. I mean, that's really cool. I think that's really cool. We've got all this, in probably 2 hours so far? 2 hours and me ranting quite a bit with some of my views. Yeah, great. I will leave this there. I'll say I'll do some reviews offline. Anything that is particularly troubling or weird, we will fix at the start of the next session. And then we'll move on to... I guess we'll build an assembler, because we won't get very far without an assembler. So I think in the next video we will build the assembler, and then we can build some more complicated programs. Great. Thanks a lot. I hope this is interesting. And if you've watched the first one and now you're watching this, thanks for sticking with it.